Hi friends, welcome to GMK tutorials. In this video, we are going to see about the different types of restoration processes. Generally, restoration means that we are expecting or we are trying to estimate the input image. Suppose if you are taking, so in this case, f dash of x comma y is the expected or maybe expected input image from degraded image so that is a basic criteria. So generally we know that in case of the spatial domain g of x comma y is equal to f of x comma y plus eta of x comma y. So that is nothing but the degraded function can be formed by adding this degraded function is formed because of some noise is added to the input image, therefore it produces some degraded image. That degraded image is nothing but g of x comma y. G of x comma y is nothing but degraded image is equal to sum of input image plus some additive noise. Okay, the same function can be represented in the frequency domain representation. Frequency domain representation is nothing but g of u comma v is equal to f of u comma v plus n of u comma v. So this is nothing but a frequency domain representation of the degraded function. So our aim is to estimate the restoration filter. So for that purpose, what are the different types of filters we have to apply to the degraded image to estimate the input image. So in that, first one is nothing but median filter. Okay, so first one is nothing but mean filter. Let us see one by one. So mean filter. So generally mean means that it is average. General meaning of mean means that average. So average means that, so from here we know that generally g of x is nothing but output image. From this output image we are estimating the f dash of x comma y. So that is a basic scenario. So from the g of x comma y, instead of g of x comma y, we can replace the corresponding terms with g of s comma t. So notation g of s comma t is the degraded input image coordinates. So mean filter formula is nothing but f bar is equal to f bar of f cap of x comma y is value is equal to. So mean means that generally you have to take, suppose as image of size m by n means total number of input pixels is equal to 1 by mn. The mn is nothing but total number of pixel values into summation. So we need to add all the corresponding values. So for that purpose, s comma t belongs to sxy into g of s comma t. So that means we are adding the g of s comma t values in the corresponding s of x comma y image, and we can divide the corresponding all the total value with respect to the mn. Mn is nothing but total number of pixels present in the input image. So from that what we are getting, f dash of x comma y is nothing but average of the pixel value. So that is the basic meaning of the mean filter. So that means each and every value of f cap of x comma y can be replaced with the 1 by mn sum of s comma t in the belongs where s represents the s of x comma y is nothing but it is a small neighborhood. So that is generally called as a mean filter. S comma y represents a set of coordinates in the rectangular sub image window of size m by n. Let it be considered. So s of x comma y is nothing but sub image. S of x comma y is nothing but s is nothing but sub image. That means we are taking a small part of the image, that is also called as a rectangular, small rectangular of a size of m by n. Okay, so that is the basic meaning of the mean filter. So a mean filter smoothes the local variations in the image and noise is reduced as a result of the result of a blurring. That means the basic intention of the mean filter means that if you are taking the average values, the image is smoothened. Okay, if you are taking the average value, the image is smoothened, therefore it leads to the blurring. Okay, so that is the basic agenda in case of the mean filter. Okay, I hope it is very clear to you guys. Okay, so next one is nothing but geometric mean filter. Next filter is nothing but geometric mean filter. Geometric mean filter. Geometric mean filter. So here also we are taking the all values, means that we are taking the average values. So the formula should be very that means a image restored using a geometric mean filter is given by, that is also here also same thing, just we can estimate the f cap of x comma y from the g of s comma t. So here g of s comma t is nothing but degraded image. Okay, so from the degraded image you have to estimate the f cap of x comma y, that is nothing but estimation of the input image. So that means the function value is equal to pi into s of s comma t belongs to sxy sub image. This is nothing but s of g of s comma t whole power 1 by mn. This is the formula for geometric mean filter. The basic advantage of the geometric filter means that we know the general representations of these values. That means what we are getting here. So where s is nothing but a sub image x comma y are the coordinates. Okay, the size of the image is equal to mn. Okay, these are the sum of the information regarding the geometric mean filter. So the geometric mean filter means that we are taking the product of the pixels in the sub image window and raise it to the 1 by mn, where pi represents the product of sums. So generally in case of the DLD we know that generally we can represent it as some SOP form as well as POS form. POS is nothing but can be represented as a pi term. Therefore, that is nothing but represented as a pi. Therefore, product of sums. Product of sums. So that means product of sums. Just we are taking the product of sums. Then you have to raise the power of whole power 1 by n. Therefore, the advantage of geometric field filter means it smoothes the image. It smoothen the image compared to mean filter. So so that what happens is that here more information is lost. More information is lost. That is one of the drawback in case of the geometric mean filter, because of it is smoothing is very high compared to the normal filters. Therefore, it leads to loss of information is also very high compared to the mean filter. So next one is nothing but next filter is nothing but median filter. Okay, so next one is nothing but median filter. Median filter means that we know that this median filter operation generally median filter. Here also same thing. G of s comma t represents the degraded image. Just we have to estimate f dash of x comma y. Okay, the formula for this one is nothing but f cap of x comma y is equal to median of g of s comma t. So that is nothing but s comma t, s of s comma t belongs to sxy. This is a formula for median filter. Okay, so here the thing is that in case of the sub image, so in this case So in this case, g of s comma t values in the sub image, these values can be of a size of m by n. These are all values can be represented in the increasing order, increasing order to take the middle value, that is replaced in f dash of x comma y location. So it gives the approximate of f of x comma y. That is a basic scenario in case of the median filter, where this represents a sub image. This is nothing but sub image. It is also called as yes. Okay, so that is the basic. In case of the median filter, what happens is that the median filter is very popular for reducing the salt and pepper noise, is also one of the advantages. Okay, so median filter is also particularly effective in the presence of bipolar as well as unipolar noise. Bipolar noise means that salt and pepper noise is also called as a bipolar noise. If the white and light pixels are same, then we can call it a unipolar noise. Those are some of the important information points regarding the median filter. Okay, so next one is nothing but adaptive median filter. So in case of the adaptive median filter, means that previously we discussed about the median filter, that is very powerful for reducing the salt and pepper noise. But this adaptive median filter can be handled impulse noise with the probabilities larger than these values. So that means this median filter is only useful up to certain extent only. If it is the probability value is large, at that time this median filter cannot be performing very effective operation. So for that purpose we will go for the adaptive median filters. It is handling the smoothing of the images even though the probability values are very high. So it can be explained with the help of some techniques will be there to analyze the adaptive filters. So in case of the adaptive filters, we have to take the statistical properties of the noise also. So for that purpose, let us see the equation for the adaptive filter. Adaptive filter. The adaptive filter equation is nothing but f dash of x comma y is equal to g of x comma y minus sigma n square by sigma L square into g of x comma y minus ml. So in case of the adaptive filter, what happens is that in case of adaptive filter means that up to we are not considering any statistical properties of the noise consideration. But in case of the adaptive filter, we have to check the behavior of the corresponding changes on the statistical filter in the corresponding region. That means the characteristics may be varying from one point to the another point. If once the selected filter is so far applied to the image without regarding the image characteristics varying from one point to another point. So in this section, what happens is that we are looking for the two adaptive filters whose behavior changes based on the statistical characteristics of the image. So here statistical properties of the image is nothing but generally two parameters we are taking into the consideration, that is nothing but m, second one is nothing but sigma square. So m is nothing but mean value. Okay, now so m is nothing but mean. Mean means that average intensity value in the image. Average intensity in the image. Sigma square is nothing but we can also call this a variance. So it represents a contrast in the image, which represents a contrast. That means color and the variation in the brightness and the representation. These are some of the important points. Moreover, the quality of the, suppose if you are observing this equation, this f dash of x comma y is nothing but output image. The estimation of the image depends on the degraded image, that is nothing but the image, degraded image can be formed by adding the noise to the corresponding g of x comma, that is also decides one parameter, as well as sigma n square. Sigma n square is nothing but variance of the noise in the corrupted f of x comma y, whereas sigma L square represents the noise in the local neighborhood, that is nothing but noise in the SXY region, as well as ML mean set, mean value in the SXY. These four parameters decides the restoration of the image in the spatial domain. These are the very important points. Moreover, this equation is only valid, the sigma n square value is must be less than sigma L square. At this time only this equation is valid for the adaptive filter point of view. Okay. So I think it gives us some more information regarding to the adaptive filter very clearly. So second, adaptive median filter is one more filter is there that is used to analyze with the help of some diagrammatic filter, that is also called as a median filter. In adaptive median filter, what happens is that adaptive median filter, in case of the adaptive median filter, so we have to follow this some of the considerations, that is nothing but Z minimum. So Z minimum is nothing but minimum intensity value, minimum intensity in the SXY, as well as Z max means that maximum value in SXY. So Z median value, so Z median is equal to median intensity in XY. ZXY represents the intensity value at a coordinates, intensity at x comma y. So S max is nothing but maximum allowed size of x comma y, maximum allowed size of x comma y. Okay. So those are the some of the important points in case of the median filter. The adaptive median filter follows the algorithm in the form of a two stages. So first one is nothing but stage number one means that it follows the algorithm like stage A, and the stage what happens is in the stage A means that, so in this consideration A1 is equal to Z median value minus Z minimum. A2 value is equal to Z median minus Z max. So Z max. So the algorithm here is nothing but if A1 value greater than 0 and A2 value is less than 0, go to stage B. You will go to stage B. Otherwise, else increase the window size. That means here we have to otherwise else increase the size of window. Increase the size of the window. If the window size is nothing but repeat stage A, else output is equal to Z median. If the window size is less than or equal to maximum allowable size, then repeat stage A. Repeat stage A for stage A, else output is equal to median value, else output is equal to median, Z median value. So this is nothing but stage A. In this case we are going to selecting the corresponding window size of the image. So let us see the second one, In the second stage, what happens is the second stage is nothing but stage B. In the stage B, what happens is that stage B, B1 is equal to ZXY minus Z minimum. At the same time, B2 is equal to ZXY minus Z max. So from this you have to select if the B1 value is greater than 0 and B2 value is also less than 0, output ZXY. In this case, output ZXY, else output Z median. So that means here we have to selecting the middle values of the corresponding stages of the information. So this represents the complete about the restoration filters in case of the image restoration technique, that is nothing but mean value. Mean value is used to take the average of g of s comma t in the neighborhood, and we can replace the f of x comma values in the restored image. Geometric mean is also same thing. We are taking the product of intensity values and raise it to 1 power n by n. Then you have to take the corresponding consideration. So that is nothing but you have to replace the corresponding values and you have to take the mean value. So that is nothing but geometric means that we can raise the power to the 1 by n. We have to replace the corresponding all values. S is equals sub image. Here also product of some values can be taken. This geometric mean is smoothens the corresponding image, that leads to so much of information may be lost. So median filter is also nothing but just you have to take the middle value of the corresponding g of s comma t in the sum image and you can replace the value in the f dash of x comma y. So that is the scenario. Adaptive filter means it is also, in case of adaptive filter, we have to take the statistical characteristics of noise. For that purpose, f dash of x comma is also depends on 4 parameters. That is nothing but degraded image, sigma n square, variance of the image, and variance of the undegraded image. Sigma L square is nothing but variance of the subimage. ML is nothing but mean value of the local neighbor. These 4 values decides the corresponding. So this is the adaptive median filter algorithm. Okay, with this, so thank you for choosing GMK tutorials, guys. Thank you for your support and all those. Thank you for